Hello. Uh, Hello. Good afternoon, everyone. Welcome to Creative Weekend Talk of episode 183. I am your host, Supriya Nayaka MK. I am so glad to have you all with us today. At Creative, we believe that learning is a lifelong journey, one that grows through curiosity, meaningful conversation, and inspiring real life stories. As a registered trust, our mission is to explore ideas that go behind textbook and non-academics, connecting learnings with a real-world experience. Vision of Creative is to nurture constructive thinking across various domains with a strong focus on non-textual, non-academic, and non-syllabus based concepts. We believe that true understanding begins when we look behind the classroom and engaging with the world around us. Our session takes place every Saturday from 3 to 4 p.m. on Zoom, and we also live stream our program on our YouTube channel Creative GBD. And today's topic of Creative Weekend Talk is on invention and inspiration. To present this, we have Dr. Kumar sir with us today. And I call Madhuri, Creative Volunteer, to welcome today's speaker and introduce him. Over to Madhuri.
Okay, ma'am. Good afternoon, one and all. I'm Sai Madhuri, Creative Volunteer. Dr. Kumar H. graduated from the University of Mysore with a degree in organic chemistry. He worked as a lecturer at MGM College, Udupi, and as a research and development scientist at Iskaya Pharmaceuticals. He then joined RV College of Engineering as an assistant professor, where he served for 18 years. As a determined and committed individual, he pursued his PhD while teaching at RV College of Engineering. During his doctoral studies, he published 16 research papers in 5 years, all in well reputed, pre reviewed international journals. Additionally, he filed a patent during this period. After successful research career, he consciously transited to administration and took up the challenge of becoming principal of Soundarya PU College, Bengaluru. He studied the system pragmatically, identified its flaws, designed and developed a plan, executed it systematically, and achieved a third rank for the state in his first year as a principal. His innovative approach, team building skills, and nurturing abilities helped the students gain a strong reputation in the short period. In 2021, he became the director of Dayananda Sagar PU College. He implemented pedagogical changes and played a crucial role in achieving a third place ranking in the state through Miss Chandana Gowda. This was the first such achievement for the 60 years old institute. Dr. Kumar is known for experimenting with educational modules to bring dynamic changes to the system. His concern for the environment, notably the major project as asphalting of roads using waste plastics at RV College of Engineering with the help of chemical engineering students in 1997-1998, which is now being adopted for road construction in India by KK Waste Management led by Mr. Ahmed Khan. Looking ahead to explore new possibilities, leading from the front and setting examples, being ready to face challenges, his humility and modesty, his interest in Kannada culture and theatre. Wow, such a great person we are having today with us. To we are eagerly waiting to listen your talk, sir. Welcome to our Creative, sir.
Thank you, Madhuri. Over to you, sir. Kumar sir, you are muted.
Good afternoon, everybody. Thank you very much, Madam Supriya. And thank all the creative people who are responsible for creating more awareness about the curiosity. The curiosity is the one that will always be there with all the individual, as an individual or as a family member. This is the one such thing that is very much essential, and I'm very very happy that you people are taking care of it, and being at Gauri Bidir National College, right? Okay, one of the best institute of this country. And I must thank Dr. H. Narsimaya. Sir is the gentleman who is behind the activities behind the National College at Gauri Bidur, or in general in this state. And his thought is also on a scientific approach and curiosity that has to be instilled, and see that all the student will come in contact with him, or any institute for that matter, should have the ability to question what is it, and why is it, and how is it happening. So that is the first and foremost approach that one should have it. And in this regard, I really wholeheartedly thank the activity of Creaactive. That itself is very very special, creative as well as active. So you need to be more active when you are when you are creative, right? Being only creative, it doesn't help. You need to be very active and see that you will reach out to the people, and see that all will be instilled, all will be enthused by the way we perform and show the things to others. So today I'll share some ideas, informations, not as an information, the ideas which can enthuse the students. I, as a student of science, what I see is the inspirations can be drawn from the nature. Nature is the best tutor, which is showing all the things for us. What is it we have to do is we need to decode and explore it, right? So in this regard, I am sharing some of my thoughts, and some of the thoughts of the great people of this world, and who are becoming great inspirations to all. So I'll start with the first and foremost thing which I have come across quite a long time back, right? So let us explore the possibilities. Nature inspires for any innovations. The innovations are there. It is mainly by the inspirations. Even my research topic is on biologically degradable polymer composites, and it is again by the nature. Nature produces the material, and these materials will not live in this world for a long time. Whatever will born will die and find its end, right? Normally I say that all the materials which are made out of here are from the five elements. So we come from the five elements and go to the five elements, panchabhuta to the panchabhutas. That the cycle has to be there. Whatever is produced, right, that should find the end. Whatever is born has to find its end, right? That cycle has to happen, and that is what is essential. Imagine if all the people who have born in on this land or been lived in on this globe or in this universe, then where we have found the place for the people, the newborn babies or newborn animals. So that is the one important thing that we have to learn from the nature. Nature has given some time for exploration, for living, for doing something good for the humanity life around us. So in this regard, we will come across many such things, and under that we have to derive certain pleasure. Not just a pleasure, we need to know how it is happening, how it is coming out to us, and how it is useful. And what is it usefulness? It is not just the usefulness that matters. What matters to us is how that is being produced and how it is processed. If you come to know those, if you have that enthusiasm to know those, if you have that curiosity to know those, definitely each individual would be innovators. As most of the kids are more curious in nature, all the kids who are newly born kids will always ask questions to the elders. Unfortunately, in this highly cutthroat competitive world, we as a elders, we as a parents may not encourage such things, right? We always have our own problems. We will be lived in only in those problems rather than the explorations of our kids, and the our ability of ourselves or inability of ourselves will may not are not working for the betterment of the curious kids. And as a result of that, they go on, switch over to the social media, YouTube. There again, if they have the curiosity, or if you direct them, definitely it is possible for them to test their curiosity. And again, it is not, the curiosity is just like a drinking salt water. The salt, the whatever the amount that you drink, that is not sufficient. It doesn't completely what fulfill your intent, right? It will always have what a need for it. So that need is very much essential. The need for or quest for the knowledge is very essential for the innovations, and for this inspirations are there around us. So we need to derive and explore and e- uh, exploit for our betterment. I don't say it is an exploitation, it is an exploration, and for that we have to be more curious. Now let me take up one important development which is happening, and so far it is not yet materialized, but it has shown a very very prominent application in the technology, right? Now let us see this. Now I will take this example. Now, you see on the screen, you are seeing that a footballer is kicking the ball. Now, what he does, he kicks the ball. You push a ball gently. When you push the ball gently, ball rolls on the floor. After certain distance, it stops. When we kick the ball, right, because of the impact, it will flow, it will roll on the floor, and after certain distance, it will stops. Why it stops? Because when it is rolling down, there is a hindrance, there is a resistance for the flow by the surface, and as a result of that, when the surface resistance is more, as the resistance increases, right, so it will gradually reduces its potential, its energy. So when the energy is less, it stops. That will happen. So, and same thing will happen, right? It rolls down and come to an halt, right? Likewise, if you keep the, now here of course on the floor there is a resistance, right? Resistance by the floor on the land or the ground, right? On the contrary, if the footballer kicks the ball in the air, what happens? It flies in the air, right? After flying it in air, there again in the air, it come across the resistance. It will come across the resistance by what? By the air. So as it moves, right, as it move, right, there again it will have the resistance by the, one second. Okay. Now there again, this ball, right, faces the resistance by the air, right, and that resistance reduces the speed, right. It will allow it, it will hinder the movement, and after some distance, after traveling some distance, it reduces its energy and comes down and rolls on the floor and it stops, right? This is the natural phenomenon that we have observed while playing football, right? So when we kick the ball on the ground, it flows, it moves, and while it is moving, it is rolling on the floor. While it is rolling, it will be in touch with the surface. The ball will be will be in contact with the surface, and this surface have resist the moment. It will hinder the moment, resist the moment of it. That resistance makes the ball to stop after certain distance. So to avoid this resistance on the floor of the floor, what I did is I kicked the ball, and here also when I kick the ball flows, right, moves, right, more than what it could be, right, and after some time, right, there again in the air, it finds resistance by the air, and that will reduce the speed, and after certain distance, it will fall onto the floor, and there again on the floor it will roll down for some distance and stops. Okay. Now next thing, let us see this action, right? In this, for this action, I make certain changes, right? So in this I make certain changes. What I will do is I take the ball, okay, I take the football, and then I take a tube, right? I will then I seal both the ends of this tube and insert this ball. I will insert this ball and seal both the ends of this tube. Say, assume that this is a very, very elongated ball, tube, circular tube, and the diameter of the tube is bigger than the diameter of the ball. You can see that this diameter of the tube is bigger than the diameter of the ball, right? Now, what I will do is I will insert inside and seal this tube, right? I will seal from both the ends of the tube. Then of course in this tube there is air, okay. Likewise, what the air is there in the atmosphere may not be same. Of course, atmosphere pressure, same amount of air is there. Now what I will do is I sealed it. After sealing this, I'll connect it to the vacuum tube. I will make a small hole over there and connect it to vacuum tube and suck all the air, almost all air, right? I will suck almost all air, or there is no air. Okay. Now after that, I seal that. I will seal it. After sealing this tube, inside that there is a ball, right? And this ball is in the tube, and that tube does not have any air. That means it is in vacuum. The ball is in vacuum. Now what I will do is I will kick this ball. I will make an mechanism to kick the ball. When I kick the ball, right, where it stops, assume that this ball, right, which is there inside the tube, it will travel all along the tube, right, till, since there is no resistance for the moment, it will travel all along the tube, right, till the end, till it reaches the end, right. So this is what will happen, right? If it doesn't have the end, that means if the vacuum tube is long, it to an infinite end, right? It may go till then. So assume this. If this is the case, right, here what is that we have done is you kick the ball inside the tube does not have the air, it is in the vacuum. Now in this vacuum, right, but look here, it doesn't have, this tube does not have air, whereas this bulb or this balloon has, or this ball has air inside, right? Okay, so this analogy, please take it into your mind. Okay, so this, there is no air here, whereas there is air in this. I kick this ball here, so it is keep moving in this, it will keep moving in the tube forever, right? A ball keep flying in this long tube, right? It keeps flying in that, because there is no resistance for the movement. And this would be the inspiration for the lightning speed train, or what we call it as, what this Elon Musk has developed, right, with the help of student in Nebraska, United States of America. That is Hyperloop Transport Technology, HTT. And this tube, this train, now here instead of the tube, it is a long tubular column, and in that you keep, instead of ball, you will have a okay, you will have this is the long tube. In this, there is, in this capsule you will have another tube similar to this, the football, and in this the people can stay there. Okay, the person is in this ball, there is air there, and with that they can respire. And this is again a sealed container. In this sealed ball is there in a sealed container. That is a sealed container is a tube, and thus tube does not have vacuum. So when it doesn't have vacuum, this tube, or the ball, or this tube, right, can travel in this tube at a speed of 1200 kilometers. That is what he has achieved, right? And this is called as Hyperloop Transport Technology. This is the experiment which was done at Nebraska. What is that he has done? He has taken students from, see, look at this, these are the one which are being done by the students. This project been initially been done by the students. He taken the projects of proposal from different countries. He shortlisted around 140 students from the different parts of the world and given space in Nebraska, in Nevada, there in United States of America, and given all the facilities which they have required, and given the task to build this tube inside the tube, and this tube is the one which will carry the people. So with this, it is possible to carry or travel at a speed of 1200 kilometers per right. This is called Hyperloop transport technology. This is how Musk has attained. And the beauty of it is, this is how, right? This is the train inside a tube. This is the tube, right? Inside that, there is another, and it can fly there, it can navigate there. And this was done by the students. The idea has been given, and they were to execute the ideas. They did it. They have done the pilot, the capsule is now, they have done this experiment. Now imagine, right? So for this, the energy required is less, and in at the same time, they have done the energy calculation as well. If the outer tube, right, that is the tube which I mentioned, right, is covered by solar cells, it produces more energy than the consumption which is required to kick this ball, the ball wherein which the person will transport of the materials or the men would be there. For that, whatever the energy required could be generated by the outer wall, right? This is the outer wall or tube, and this tube, if it is covered by the solar cells, flexible solar cells, and it is possible to generate solar energy. With that itself, we can have the hyperloop transport technology, and that is the one which was developed by a physicist and an economist who is none other than Elon Musk, right? Let us not worry about what is the present status of this gentleman, but look at the way he has come up. He is as a person from a small beginning. I will come to that part. Now here, let me focus on this, right? This is possible. Here, inspiration is kicking the ball in air. So this is how we can tell our students that yes, come on, it is, this is been done with the help of it. So had this been gone to the minds of the people in the early stage itself, then the people would have come out with something which is very unique, right? Much earlier than the Elon Musk. And why it has not gone to the minds of the people, and the people are paying this for many years, why it has not gone there, why they have not given the thought to it, right? That is the one which is bothering me, and of course people like you could be thinking about this. So this is one such simple experiment, simple act that we are witnessing every day when we are playing the game, right? Why not this becomes an inspiration for to I mean, a transport facility like this much earlier than Elon Musk? That always haunts me, right? And the cost of it is, as it been compared, it is one tenth of supersonic, super speed bullet trains, right? That cost is less. So this is the experiment which was done in the US, right? That is in Nevada. This is the tube which they have developed, right? So this was done in Nevada, and it is successfully done. And this is how this is the, of course, architecture view of it, right? Okay, so this was successfully tested. So this is the first experiment which was done by the students. So in this capsules, they could able to make what the capsule to move inside this, right? So that is made to travel at a kilometer. First they did it at 94 km per hour. So that was the first experiment which they have done. So it was done that, right? First outsource, this is the outsourced project. And after this, what he has done is he has published as an open source. He has published this as an open source. It was not been patented. So this later on been taken by the person who is in charge of Virgin company, Virgin Airlines, right? So he is pursuing there in UK, and we are very fortunate that our own people, the people in Madras, right? Okay, this was later taken up by Norway. Norway wanted to have this type of technology all along the coast, along the country. Abu Dhabi is interested in it, China, London. Of course, in India, already Chennai, that is IIT Madras, have already constructed recently, last now December. They have already constructed this tube, right, for the experimentation of the cells like this, right, experimentation. So our own students, right, our students are from IIT Madras are doing this, right. So this is an open source, and this open source, as I mentioned, being taken up by Virgin Airlines, and they are the people first. They had collaborations earlier here, and now Chennai IIT is pursuing, right. So he is the gentleman who is responsible for this. So this gentleman is none other than Elon Musk, right. So he basically from South Africa, right. In fact, he is the son of electrical engineer and a model, Canadian born model, right. Okay. And he started me as a first, he he has published an article in PC. He got $500. From that $500, which then he purchased many companies, starting from PayPal, right, PayPal. And then after that he went on to do then how the ventures which he ventured into. This is the experiment which he has done, right. Okay. And now after that, his role in SpaceX. See, this gentleman, basically a physicist graduate, and enrolled himself at Stanford University for PhD. He attended for one day and then quit. He is graduate in physics as well as economics, physics and economics graduate. And he, as an entrepreneur and as a scientist, he could imagine. And in fact, this is the gentleman, right, who believed that neuroscience would be the future. Neuroscience would be the future, and felt that neuroscience becomes one of the important tool for transferring the information, right. We are having a pen drive to transfer information from one system to another system, right. In future, we may have a system wherein which the information which is required for us could be transferred through a pen drive or even the system, right, by what not necessarily a pen drive, by sending the signals. Already the scientists in Germany, right, are able to control the minds of the person suffering from Alzheimer disease, the person who is suffering Parkinson disease, right, the person suffering from this are being controlled with the help of the by sending the signals, right. So that means our brain, our mind could be under the control of another system, right. And that is possible in the future, right. Now this person believed that neuroscience and neurotechnology becomes the future, and started neuroscience. Neuralink is another company, SpaceX. And of course, this is the privately managed space research laboratory. Recently we know that, right, how our Sunita Williams has landed here in the water, right. Okay. So the landing process also been developed by him. And in fact, when he thought of having a separate or private space research laboratory competent to NASA, people as overloved at him. At that time his experience was nothing. He was manufacturing Tesla. He is the Tesla car, owner of the Tesla car. And even this Tesla idea of that car is not his. Actually, they were the original owners of it have worked for him later worked for him. But when he had the idea of a SpaceX, he took those people to Russia and to the KGB people, and he explained that I am running an automobile industry there. I want to have a space research laboratory, and I have to work on the rockets. The people laughed at him and sent him back. By laughing, they sent him back. Now you can see that he went and brought our Williams back, right. And this is what he could do, right. That's what our people can do, right. If you have the scientific temperament, if you have the curiosity, if you have, you can derive many things from our nature. So this is what this gentleman has done it in the short span of time, right. And he is such a fantastic person as a researcher and as an entrepreneur. And he knew that later that even in the automobile sector, right, that he knew that solar cars are very important, that electrical driven cars, especially EV electrical vehicles, are very important, and visualized it, and still is working on it. And he knows that that plays very important role. And again, he worked on, of course, he was also, giving cautions and threatening us about what will happen with artificial intelligence, right? If at all this artificial intelligence, already AI is becoming general, artificial general intelligence, right? So if general intelligence, right, artificial intelligence becomes artificial general intelligence, and that becomes artificial super intelligence, imagine ourselves where we would be. If the system, if a computer, if a robot thinks better than us, if it thinks better than us, if it can execute better than us, because we learn by knowing that way. So we say that, yeah, this is a pen, this is a pencil, this is a rocket, this is blue color, this is red color, this is black color. By looking at it, by knowing it, by memorizing it, by repeatedly looking at that, we see that. And the same education is being given to, and what instrument, that instrument has huge amount of data. Now what is happening? Data, it becomes information, information and processing becomes knowledge, and this knowledge and further processing become creative wisdom, right? So creative knowledge, right? So from data to information, information to knowledge, knowledge to the wisdom or the creativity. And if that happens, you can just imagine how we will be. A small chip can hold, like a small robot or a small computer can hold huge amount of data. Even our brain is nothing but a storage machine, and then that storage machine, our viveka, our consciousness, our wisdom will process it, right? When you look at that, as I told now, right, how the ball has moved and how the resistance has made the ball to stop, and why this cannot be a creative insight for the development of new material. Just like that, if that animal, sorry, if that machine thinks, where you will be. And they, it will have more amount of information, more processing of data, and what could happen, right? It is a question mark. Whatever she Dr. H. Narasimha used to say, question the process. You question me as well, definitely. Yeah, you do that, right? This is what we have to do. So this is how the process is possible. Now, of course, let us not worry about what this person's cost is. Okay, he is also co-chairman. Of course, he came out of it, and he, the way in which he born as he is not from a very awfully rich family. Now he has become a number one. Actually, at the one time he was number one after the separation from his wife. Of course, this wealth has come down, but even then, his wealth is humongous. It is mainly because of his creative outlook. Right now, let me see some of the other things which we see in our day-to-day life and in our nature. Right, through that could be the important thing for our important aspect for our curiosity, for our innovations. And we have come across many such things. Let me take some of it, right? Okay, some of the natural inspirations that we can think, right? Okay, now think about the kingfisher beak and the bullet train, right? Kingfisher beak, so the beak of it, right? It can this kingfisher can simply dive into the water, with a less minimal splash. The resistance is less, right? It can with less minimal splash because of the design. Because of this design, right, it will have less resistance. Same thing with the train in Japan. So this becomes an inspiration for this new technology, right? So this reduce this noise, this tunnel noise, and boost energy efficiency. Noise of the this reduces this tunnel, right? Okay, this is the one which reduce the sound. One thing is, here you will have a rest noise, right? Tunnel noise, and also boost energy efficiency. So this is again inspired by this beak of the kingfisher, right? This is the one inspiration, right? This we have seen it. This we know that very well, right? This is known. And again, this is the one, the building which is there in Zimbabwe, right? The termite mounts, Hutta, right? This okay. This is again, this termite mounts regulate temperature throughout the self-insulating tunnels because of the perforation. We know that, in fact, our all our houses earlier days, it used to be made out of mud, okay, and there the perforations, they used to use even the grass, even, yeah, grass also along with it, and also the thatched roof, right? The thatched roof with the grass. Okay, there again, we used to have a cool environment, right? Even today, even in South Kendra, or even Shumaga, right? That is in Malnad district. They use that, and of course, the building which is, this is actually basically a self-ventilating tunnel, right? Okay, they are similar to this. There are the buildings which are 90% energy efficient, right? So this will control, cut short or reduce the energy, right? So this will again, right, these kind of ventilations will also regulate the temperature. Now, and always, very old buildings will have a cooling effect impact because of the perforated structures which are there in some of the structures of the system, or structures for that matter. And this is very, very, very much well known, right? Lotus leaf, right? Lotus leaf, and also self cleansing surface. This lotus leaf, right? The water cannot adhere onto the leaf, though it is there always in the water. The water cannot adhere onto the surface. There, the surface has a nanostructures. It has a nanostructures, and these nanostructured structures, right? Because of the structure, right? This cannot adhere. The surface tension get reduced, right? This cannot adhere onto the surface, and as a result of it, right, it will not stick onto it. Similar technology being adopted under in the fabrics. It is being adopted in the fabrics. So this becomes an inspiration for the innovations. The innovation is this fabric will not adhere water. It doesn't adhere water because this surface structure, right, which will have nanostructures, especially nano compounds, nano materials, nano surface materials, nano particles which are there on the surface of it, will not allow the water to spread across, spread along, and that reduces the adherence, right? Basically, dust is mainly because of adherence or absorption of water and oil, and as of subsequently, water and oil on the surface of the fabric adheres or absorbs, absorbs. Adherence could be either absorption, that is completely submerged into the body, or adsorption, that is sitting on the surface of it. It can happen. What absorption of what? Absorption of dust which are there in the environment, and thus our body, and also what the fabric will get, will become dirty, right? And if that surface is coated with nano paint or nano surface, nano fabric material, right, that also prevents. So it could be a nano paint, the nanoparticles loaded paints, right? It is possible. There are many, many nanoparticles, nanotubes, and nanoparticles are there to be used as a suspended materials in the paint and lacquer paints, and that when it is spread onto the surface of the surface, right, that nano particles which are present there in the nano size, right, that is 10 raised to minus 9 meter, right, that will not allow the submersible liquid to adhere or absorb onto the surface. First, normally adsorption and absorption takes place in two steps, or absorption or the deposition will happens first by adsorption. That means it will sit like this, the water droplet sits like this. After that, it will get absorbed on the surface and flattens up. Once it flattens, right, that is by the absorption on the wet surface. The dust which is there in the environment will sit and becomes dirty on the surface of the fabric or anything. So if it is not absorbing, the dust may not sit here, and thus it is easy. And if at all it is there, that can be easily cleaned by either vibrations, by shaking, or by the current of water. You can cleanse the surface of the fabric. So this is one possibility is happened already, right? That is happened. Okay, so that is there, right? Next, shark skin has become inspiration to develop speedos swimming suits. Speedo swimming suits first developed there by the speedo company, right? The swimming to design is similar to the what a shark skin. So this denticles, denticles, okay, this will reduce the drag in water. This reduces the drag in water, and as a result of that, it will enhance or facilitate the movement of the swimmer, right? So enhancing the swimmer speed, that is possible, right? So that is by the design, right? So this is again by the natural phenomenon which is found in skin of the shark, right? So this is another natural phenomenon that is very much there, and this is well known to all of us. Bat, right? The bat echolocation, right? Echolocation and the sonar, right? So here, this from this shape, we can send the signal, what the sound waves, right? Depending upon the reflections of this, right? We can come to know the objects which are there at the other places, right? So this is again, the bats becomes an inspiration to develop this. It becomes an inspiration for sonars, right? It becomes sonar radar systems, right? This is a sonar, that is sound. By sending the sound waves, it is possible to locate the objects, right? Okay, different. This is for this bats are the reasons for it. And we, of course, this is a normal thing with we believe that it doesn't have eyes, and it will get the now, okay, it will send the noise. So by from the reflections, it will come to know whether there is an obstacle or not, right? It is there or not will be known by this bat, right? Bat sends the noise, and by from the obstructions which will come, right, it will identifies that there is an obstruction, there is that is not its path. Likewise, for our recent technology, for recent navigation system in our ships, we can have this kind of sonar, and this can have this can be used as a technology. So again, for this, nature is the inspiration. So likewise, we can have many such things, and these are to be instilled amongst the student. These are the things which are very much essential. This is what we have to inculcate amongst our students. So this is the one which is missing in the present generation. Of course, there are certain schools, there are certain colleges, there are certain people like Creactive are working on this, right? Because by knowing the responsibility of individuals, by knowing what is happening around us, amongst the students in the schools or in the college, of course, for the other college, now what is happening is whoever takes the admissions here at our college also, right, wherever they are, right, especially PUC college, what they say is, what is their goal? I want to become a software engineer, I want to become a what AI specialist. That is the ultimate goal. Either one end is AI or software engineer. Nobody wants to become a scientist. Very few people wants to become a scientist, or the developers, or the teachers, right? You're not even teachers also, the number is coming down. The reason is majority of them wants to make the quick buck. Majority of them wants to make money as early as possible, and that being the case, right, we are not the things are not happening properly at the proper way it has to be done. If at all they are doing the research in the engineering as a project, how many projects from the engineering college has come to the market, has come to the field, has been marketed either by the industry, either by the college, or by someone, right? Though they have the competition, though they have the collaboration with major companies here in Bangalore, there are many companies, both software as well as the non-software company, other technical companies. Though they are coming up, but the quantity of the students that are being produced and the quantum of research that are happening is not up to the expectations. So by taking this clue from taking this and being here in the education system for a long time, we here at Dayananda Sagar College to encourage such people, to motivate the students who are interested in research, we are conducting national level competitions for the students of ninth, 10th, 11th, and 12th every November, right? Every since 3 years, now here since 3 years, we are conducting national level innovation exhibition design award. We are giving that award. It carries a cash reward, and it is a national level competitions, right? Those who are listening to me through this media, either through what's YouTube, WhatsApp, or any social media, please take it forward. And if you have any questions in this regard, if you want to take the research, if you want to enhance the curiosity of the students, right, we have many such things in amidst us. In fact, if you take the my own research, right, actually we know that polymer, in fact, I have done the research on asphalting of roads using waste plastic. This was done in the year 1997, 98 as a product of as a part of Bangalore University project. There, the idea is to reduce, because we know that the plastic that we are using are not able to be digested by the enzymes which are there in the nature. Soil cannot digest, air cannot digest, water bodies cannot digest that. So as a consequence, these plastic materials will live in this on this surface for hundreds and hundreds of years. So what I've thought is, instead of converting, now if it is there on the earth, if it is there on the ground, what happens is these plastic particles which are there on the surface, right, due to thermal degradation, it will degrade and reduces the size, but not the not chemical degradation. Large molecules should become simple molecule. So when I as a material is burnt, right, this will be converted to carbon dioxide and water and other oxides of the matter material which are there in our body, right? So likewise, if I burn the plastic, it will give rise to other unwanted hydrocarbons, and that hydrocarbons would be polycyclic hydrocarbons, and they are responsible for got cancer. They are all carcinogenic. And at the same time, on the if the plastic material is there on the in the environment, due to thermal degradation, what will happen? The size of the particle reduces. It becomes very, very fine particle and becomes a part of the clay or the soil. And in this soil, we have salt, we have inorganic material and organic polymeric material, and we call it as microplastics. And these microplastics eventually goes to the water body. From that water body, it goes into the animals like fish, etc., and thus fish will be eaten by us. And as a result, the fish eats the while it is drinking, while it is breathing, it takes that particle, that is plastic particle which was there as a part of either pen or the carry bags, will reduce to small particle called microparticle. And this microparticle will get into the water body. From the water body, it gets into the fish. From the fish, we eat the fish. When we eat the fish, through the fish, that plastic particle gets into our stomach, and in that stomach it cannot be digested. When it cannot be digested, it stays there and it will affect our health. Microparticles are affecting the health of hundreds and thousands and millions of people all along the globe, and awareness amongst this is being created. So to reduce this, what I did is, I have taken the plastic place, our plastic waste plastics, right, shred it into pieces, mixed up with bitumen, that is tar, and added to the asphalting to construct the road. To 8 to 9% we can add, and there it gets into the bitumen and becomes the part of the road. It becomes the part of the road. As a consequence, it will the strength of the road has been increased by 3 times. And it was tested by then consultant to the government of Karnataka, Professor CEG Justo is the consultant. He was a professor of Bangalore University. He given the report, and later on it was approved, right? So there, by using those, say 8% of waste plastics in the construction of road, we could able to increase the strength of the road by 3 times. That means life by 3 times, right? So that is being followed, and it was done by the my students at RV College of Engineering, right? The students who have done these projects are Gangadhar, Ahmad Khan, Vinay Raikar, and Manmohan Madhusudan, right? 4 students have done this, right? Now Ahmad Khan relative is uncle is taking up this project further, and they are implementing as a KK Waste Management and laying roads since many years in Bangalore. KK Waste Management, which is there in Bangalore, right? In fact, he claims that he has done this, but it was done by my students. It is my dream. It was done in 1997, 98 in the to RV College of Engineering. It was a part of Bangalore University, and later on it was again verified by one another professor in Bangalore University, and a student who did this as a MCom ME project is Srikant. Now at present, I hope he is in Canada. Of course, Canada is another country which is implementing. There again, when I use that, the India, what my for me the inspiration is, when we are young, we used to play on this waste plastics. We used to have what a normal what fireplace. At that fireplace, we used to put the plastic into the fire, and when we put it into the fire, that used to stick and burn with a stingy odor, right? Very very stingy odor. And from there, we used to pull out. When you pull that gummy plastic mass, it used to become fiber. It used to become fiber. When a fiber is added to any mortar, it will reinforce. For example, our RCC, here there, the steel bar is a reinforced rod, and that is fibrous, that is a rod which will reinforce the concrete. So same technique being utilized, same inspiration was there when I used those plastics in the reinforcement. Plastic is hydrocarbon. The residual mass, which that we call it a star, is a residual mass of the fractional distillation of petroleum. That is also high molecular weight hydrocarbon. So there, one is in fibrous form, other one is in fluid form. So there, into the fluid of tar, we have introduced the fiber, and that fiber has reinforced the tar, and thus strength of the road has increased. So these are all the small inspiration that we can get it from the nature, right? So these are the things which I wanted to share amongst all of you, right? There are if there are any questions, I'm very happy to address it. I have taken only very few examples, right? So my interest is to create enthusiasm and create curiosity, and the curiosity is the main what the thirst of this creative and active group, right? So this is what is that I have for all of you, right? If any of you have the questions, any doubts, any questions, right? I'm very very happy to answer those questions. Any questions?
Thank you, sir.
Yes, madam.
So it is open for questions now. If anybody having doubts or questions or any information regarding this, you can give. You can unmute yourself and talk.
Any questions?
You can put it in the chat box also. So I think we don't have any questions, sir.
Okay, thank you for patient hearing. I once again thank madam, okay, Supriya madam, and all the people who have given your patient hearing to what I have have for you guys. Okay, thank you very much once again. Thanks once again. Please, thank you.
Thank you for this wonderful section, sir. Thank you so much.
Thank you, madam.
Thank you, sir.
Okay, just like okay, there is some you are chatting. Just like you can post the see things you will during the meeting. Okay, no, that is nothing. Yes, madam. Thank you.
Okay, sir. Thank you so
Thank
much,
you
sir.
very much. Thanks a lot.
So
Yeah.
shall I end it, sir? Shall I end it, sir?
Yes, madam. Please. I'm leaving from that. Okay.